Hello, everybody. Today we are doing pre-algebra, chapter 4, lesson 12. We are going to be finding formulas. So we have been talking about using addition, subtraction, multiplication, and division to find missing variables or missing values, right? Today we are going to try to find missing values for shapes. So let's get started. You are going to need to write down the following three formulas. The first one, you already know. This one is the perimeter of a rectangle. Perimeter of a rectangle. And as you know, a rectangle is any four-sided polygon that is enclosed, okay? And the perimeter, as you know, is composed of the length and the width, okay? And the equation for perimeter is perimeter, or P, is equal to 2 multiplied by whatever the one length is, and that's in parentheses, plus 2 times whatever the width is, or W, right? So we need to write that down. So in reality, the real equation is perimeter is equal to length plus width plus width, but you can translate that into perimeters is 2 times the length, 2L, plus 2W. All of that is saying the exact same thing, right? So you're going to need to know that equation first. 2 times L plus 2W equals P, or the perimeter is the length plus the width plus the width. Okay, that's the first one. The second one you're going to need to know is the area of a rectangle. So first we did perimeter, let's do area. The area, and you can remember to pause the video if you need to slow down. The area is slightly different. And the area of a rectangle is simply the length, one length, multiplied by one width, or L times W, or LW. Because remember, when you have variables right next to each other, that still means multiplication, right? So if, this width was worth 5 and the length was worth, 10, the area would be 5 multiplied by 10, which would give you 50 units squared. Okay, we remember that. So make sure you write that area formula down. And then finally, we have volume of a box. So I'm going to erase all this. And remember, a box is a three-dimensional shape. It has length, width, and height. So for example, if we were drawing a three-dimensional shape, it might look like this. Here's the length, here's the width, and the height is coming later, right? So we got boom, 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 and then we draw the exact same shape again on top of it, where we have boom, boom. I'm trying to make it as even as possible, but that is clearly not working out. Perspective. There we go. There's our box, right? Actually, pretty nice little box. Okay, It's like a Google box. And the area of a box is all the space inside the box, right? Area of a box is area is the length multiplied by the width multiplied by the height. So, I mean, I didn't really do it in the exact same orientation, but there's height, there's the width, and there's the length, depending on how you orient your box, right? So for example, if the length is, I don't know, 3 inches, the width is 2 inches, and the height is 5 inches, it's simply a matter of area being A is length times width, times height, or replace the variables, you're going to get 3 times 2 times 5. Your area will be 3 times 2 is what? 6. 6 times 5 is 30. It would take 30 little squares, little boxes, blocks or cubes to fill up the entirety of the inside of this shape. Okay, so that's area. So what we're going to do today is we're going to start off with some of these measurements, and then we're going to try to figure out what the other ones are, right? So let's try that out. So if the question says, oh, I'm just going to write it out. Give me a second. So if the question asks you, sorry about that, find the width I'm waiting for the zoom to pop up here. Find the width of a rectangle Let's just get it back here. Let's try that again, sorry. There we are. Find the width of a rectangle that has an area of 18 centimeters squared and a length of, I should make it blue, 6 centimeters. All right, so here's basically a riddle, right? We need to try to figure out what a missing width or what one of the sides of the rectangle are. Here's how I would start with this problem. Since I know I'm dealing with shapes, I'm going to start drawing the shape. I know it's a rectangle, right? So a rectangle looks something like this. What else do I know about it? So we know that it's a rectangle, check. I know that I'm going to be finding the width, right? And what is the width? It's the short side of the rectangle. So I don't know what those are. But I also know that the area, the whole thing, is 18 centimeters cubed, right? So what I do know is that the area is 18 centimeters squared. And that's going to be important later. What else do I know? I also know that a length, right? One of them is 6 centimeters. So if this is the length, and this is also the length, I know one of them is 6, right? Which means the other one is also 6 because rectangles are even, well, most of the time, are even on both sides. Okay. Now, let's see. Based on the information I have already given you, which formula would we use? Well, we're looking for the area of a rectangle, right? We already know what it is, but we have an equation for it. And the equation for the area of a rectangle was area is equal to length times width. Okay, so if that's true, I also know, based on the information provided in this problem, that my length is 6, right? I got that from right here. Boom. So I replace the L, or substitute it, with the 6. And then I rewrite the problem again. But I also know that the area A is 18 centimeters, right? So if the area A is 18 centimeters, I know I can replace this area A here with what it actually is, which is 18 centimeters. But I don't really need to write that right now. All I need to write is 18 is equal to 6 times W. Because eventually, length times width will become area, and the area for this rectangle is 18 centimeters. So now all I need to do is what I did before. I notice I have a missing variable W. I need to find it. I notice I also have multiplication. How do I get rid of multiplication? Well, simple. I use division. So I divide by 6 to get rid of the 6 on this side. And what I do to one side, I must do to the other. 6 divided by 6 is 1. So now I have 1 times W here equals 18 divided by 6 over here. 18 divided by 6 is 3. 3 equals 1 times W. So 3 equals 1 times W, which stands for width. Well, 1 times anything is itself, so 1 times the width is the width. Nothing happened to the 3. 3 is equal to W. So let's test that out. If my width is 3 and my length is 6, will I get an area of 18 centimeters? Well, let's try it. If I know that the area of a rectangle is length times width, and I also know that according to this problem, this area is 18, and I know for a fact that my length is 6 based on the diagram, and now I'm testing to see whether or not the width is 3, so I put in the 3 for the width. Now all I have to do is test it. 6 times 3, what does that equal? Well, it equals 18. Does 18 equal 18? Yep, it does. Then it is good. Our width is 3. 3 what? 3 centimeters. Not centimeters squared, just centimeters. And there you have it. That's how you reverse engineer an area problem. Let's try reverse engineering a perimeter problem. All right, so if they say, find the length of a rectangle again with a perimeter. Now we're looking for perimeter, different from area, of, and how much is the perimeter worth? 14 inches. Notice how it's not 14 inches cubed or squared because it's just perimeter. And a width of 3 inches. All right, again, let's start with what we know. What do we know? We're building a rectangle. So let's do that first. Here's my rectangle. What do I know about the rectangle? I know we are looking for the length, so that's going to be my missing variable, right? I don't know what the length is going to be. And remember, the length is the long side. Length equals long. I know that the perimeter is 14 inches, so what I do know is that the perimeter P is 14 inches. I also know that the width is 3 inches, right? So the width W on both sides is going to be 3. Okay, so we have now exhausted all the information in the problem. Now I look back at the notes, Mr. Thomas, I gave you earlier. Perimeter, we said, was 2 times the length, or 2L, 2 times L, plus 2 times the width, or one width, right? So now let's see if we can fill out any of that information. We know perimeter is 14, so we can plug that in. We don't know what the length is, so we can't do much with that. All we know is that's 2 times L. Do we know what the width is? Yes, it's 3, because they told it to us and it's on the diagram. So it's 2 times 3. All right, now all we have to do is start seeing what we can solve. All right, 14 stays 14. 2 times L stays 2L, because we can't do anything with that yet. Plus 2 times 3, 2 times 3 is 6. And of course, we could have used PEMDAS to try to start solving that, right? So now I have an equation with multiple operations. I've got 2 times L and I've got positive 6. If we remember from 2 lessons ago, all I have to do is undo the addition first, then undo the multiplication, and then I have my answer. So first, let's undo the addition. How do I undo positive 6? Well, I need a negative 6, the inverse operation. What I do to one side, I do to the other. 14 minus 6 is 8. 8 is equal to 2 times L. I'm going to write the L normally. 6 minus 6 is 0, so that cancels out. And now I have 8 equals 2 times L. How do I get rid of multiplication? Well, I divide. I'm trying to find out what L is, the length, so I divide by 2. What I do to one side, I must do to the other. 2 divided by 2 is 1, so I got 1 times L. And then I have 8 divided by 2 on this side, which is 4. 4 is equal to 1 times L. Since 1 times anything is itself, 1 times L becomes just L, which is what we were looking for, the length. And so we claim that each length is worth 4. And so now, to test the perimeter, all I have to do is plug in L to the original equation. So we're saying that the perimeter P is 2 times L, or 2L, plus 2 times W. Let's fill in the information we knew before. We knew that P, perimeter, was 14. We now know that L, or we think that L is worth 4. So let's put in a 4. And we knew before that W was 3, right? So let's plug in a 3. Now let's do PEMDAS. I don't have parentheses. I don't have exponents. I do have multiplication. 2 times 4 is 8. 2 times 3 is 6. Now I use addition. 14 plus 6 is, or I'm sorry, 8 plus 6 is 14. Does 14 equal 14? Yes, it does. And so it works. So we know for a fact now that the length, or one side length, is worth 4. For what? 4 inches. And there you go. That's the basic way to solve these problems using all the steps that we've learned in this chapter. We learned how to use inverse operations, how to solve using multiple operations, substitution, and now it all comes together when we're trying to solve for lengths of various polygons. So first step, read the problem. Second step, draw a picture. Third step, fill in the information you know. And then after that, solve for the variable that is missing and make sure to prove your answer. All right, hopefully that helped. If you need any more questions or need any more assistance, let me know. Good luck. See you in the next video.